Hello, welcome to a new video course I'm going to be doing on trigonometry. We're going to be going over the fundamentals of trigonometry, and we'll see how far we can take this. And we're going to be starting off at the very basics in lesson 1, what an angle is. Well, not what an angle is, but angles measured in radians. So, how do we define a radian? Well, an angle theta is formed between the x-axis and the terminal ray. This is our theta, right? And it actually has a unit circle. Sorry, let me correct myself. It's a circle with some radius, and the angle subtends an arc, right? You see the arc right here? It subtends the arc. And theta is defined to be, in radians, the arc length divided by the radius. So, note radians is a unitless measure because arc length and radius share the same unit. One radian actually doesn't have a unit. And this is actually pretty cool. So here's an example of how we would apply this. Let's say you know the arc length of an arc is pi over 3. Find the angle that is, that subtends to this arc. Well, if the radius is 1, by the way, then theta is pi over 3 over 1, or it's just pi over 3. Theorem 1.1 or proposition 1.1, the angle of a first circle is 2 pi. Proof, we're going to let the radius of the circle be some positive number, r, and the arc that is subtended by the terminal ray, or by the angle actually, has a length of 2 pi times r by definition of pi. This is our definition of pi. It's some constant, such that that's true. So theta is the arc length over the radius, which is 2 pi r over r, which is 2 pi. In other words, theta, which is the angle of a circle, is 2 pi. So this means that a straight line, which is half a full circle, is going to be pi. So just this would be angle pi, and this, which is 1/4, which is a right angle, it's just pi over 2. Now we're going to recall our basic geometric definitions of sine, cosine, and tangent. You may have learned in geometry that sine of alpha is a over c, cosine of alpha is b over c, and tangent of alpha is a over b, and sine of veta is b over c, cosine of veta is a over c, and tangent of veta is b over a. Remember, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And it's actually really useful because we can apply this a lot everywhere, but notice it only works for angles between 0 and pi over 2. It would be nonsensical to consider pi over 2 because you can't have two right angles in a triangle, at least in Euclidean geometry. And you can't have an angle that's 0, and of course you can't have an angle greater than pi over 2, because then the sum of all the angles would be in the triangle would be greater than pi, or as you may have known, 180 degrees. And again, like I said, in Euclidean geometry, that's not possible. So we're going to need to expand our definition a bit, look over our horizons per se. We're going to redefine our trig functions so that it would be most useful. If you know anything about math, we want it to be universal, and if we decide anything by convention, then let's try to preserve that and keep our result to be true. But this time, we wanted to not only preserve our original definition, but also work for any angle. So we'll define sine and cosine to be as follows in the unit circle. Let's say you have angle theta. The sine theta is defined to be the y-coordinate of this point of intersection with the terminal ray of the angle and the circle, and cosine theta is the x-coordinate of that. This definition works for any theta. Proposition 1.2.1, and that is if theta is between 0 and pi over 2, sine of theta is opposite over hypotenuse, and cosine theta is adjacent over hypotenuse. We'll prove that our definition actually does preserve our old definition, and this is a property. Here's our proof. We're just going to take this to be our triangle. This can be formed in any quadrant. Either way, we're still going to get the same exact thing. Oh, sorry, no. This is for quadrant 1 since theta is between 0 and pi over 2. So in this case, we have opposite over hypotenuse is sine over 1, adjacent over hypotenuse is cosine over 1, or, well, we get our theorem that we were looking for. So it works. We've preserved our original definition, our new definition, and from here on out, we're going to kind of forget we ever learned that, per se. I mean, no more using SOHCAHTOA. We're only going to be using the geometric definition on the unit circle. This is just a property that we've proven, and it only works between 0 and pi over 2. So we're going to define tangent now. Now the tangent axis is the line that passes through the point 1, 0 and is parallel to the circle, parallel to the y-axis, and it also happens to be, you could also define it to be, it goes to 1, 0 and is tangent to the unit circle at 1, 0 and perpendicular to the x-axis. So that's just what the tangent axis is. It's basically just this line. So to create we're going to create a tangent axis, which is a line through 1, 0 and it's tangent to the unit circle at 1, 0. Tangent theta is defined to be the y-coordinate of the intersection between the terminal ray and the tangent axis. That point, the y-coordinate is tangent. The x-coordinate's 1, well, and I think it's obvious why. Well, because the tangent axis, the line is x is equal to 1, so only the y will change. Here we have 4, if you want to take a look at it, 4 different propositions, which are basically that tangent theta is sine over cosine for all different angles. If you want to take a look at it, you can pause, check over the proofs. But the point is that for any angle, we get 1.3. For any angle, tangent is sine over cosine, which is a combination of these 4 cases. So we're going to now prove that tangent is opposite over adjacent, and once we've done that, we can, relax, knowing that our new definitions actually do work. So this is our triangle, and we have hypotenuse of 1, and legs of sine and cosine, and angle theta. What is opposite over adjacent? Well, it's sine over cosine, and by 1.3, in fact 1.3.1 works, but by 1.3, which is the more general case, we have that tangent is sine over cosine, so tangent is opposite over adjacent. You see how we're using it now? And we're going to define cotangent as well. Cotangent is literally just, you know how we have the tangent axis is 1, 0, cotangent axis is 0, 1, but same exact type of construction. This time the cotangent of the angle is just the x-coordinate of that. And I'm not going to include the proof that cotangent is cosine over sine because it's actually very similar to the proof for tangent. So you should be able to do it as yourself if you want to leave it as an exercise. So far, we've only talked about angles between 0 and pi over 2. And how we're going to talk about 3 pi over 2 or 17 pi over 2. All of these big angles that aren't precise. Well, first we want to prove that if an angle is equal to 0, then it is also equal to 2 pi. Those are logically equivalent. Well, we know that the measure of an angle of a full circle is 2 pi, but remember, 2 angles on the unit circle are by definition the same. We talked about this. If the terminal ray are equal, so if we have the same exact terminal ray here and here, we have the same exact terminal ray, so the angles are equal. Now, we know that the measure of an angle of a full circle is 2 pi. We already proved that. But if the arc length is 0, then the angle is 0 over the radius, which is just 0. And it's the same exact angle as 2 pi because the terminal ray is the x-axis. It's the right side of the x-axis for both angles, so they're the same angle. So we've proved that if an angle is equal to 0, then it's also equal to 2 pi, but we can actually add as many 2 pi's to any angle as we want. Since it's adding by 0, remember the additive identity allows us to add by 0 as much as we want. So for any angle, the angle is just equal to the angle plus 2 pi n, where n is an integer. Here is an example. 3 pi is 2 pi plus pi, which is just pi. And we're taking the principal argument of the angle. It's called the principal angle or principal argument, as you might hear, because we want to only consider between 0 and 2 pi. So in this case, for 51 pi, well, it's 2 pi times 25 plus pi. And the 2 pi plus times 25 is just 0, so we just get pi. Now, using this, we can actually establish the periodicity property of sine and cosine. Since remember, for any theta, we have that's true. And if you learned in pre-calculus what periodic functions are, then, or if you're not taking pre-calculus, you haven't taken it yet, or you're taking it at the same exact time as this course, you may not know what a periodic function is. A periodic function is basically a function that repeats itself on a certain interval, and that it's a certain period, k. So f of, where the period is k, f of x plus or minus k is equal to f of x. In this case, if you look at this, the graph for sine, it's going to look like this, and then it's going to repeat itself. Okay, no, that was bad. It's going to look like this, then it's going to look like this, then it's going to look like this, then it's going to look like this, and it just repeats itself for on and on forever, actually. And finally, we're going to define cosecant and secant. Although we'll probably only talk about sine and cosine for a pretty long time, we should still know the definition of cosecant and secant, and also the property that cosecant is, well, of course, 1 over sine, and secant is 1 over cosine. So we're going to take a tangent line at the point cosine sine. So tangent line right here at this point, which we also know is cosine, comma sine. Cosine of the angle, by the way. You often see people sometimes just say cosine and omit the angle, but it is always cosine of the angle. Do not just write cosine as itself, okay? That doesn't make sense. So we want to draw a line tangent at the circle at that point, and it'll intersect the x-axis and the y-axis at 2 points respectively. And here's secant, the x-naught. Cosecant is the y-naught by definition. So final thing that we're going to say is that, well, I'm not going to prove this because, again, I can leave that as an exercise for you, that secant theta is 1 over cosine theta for any angle, and cosecant theta is 1 over sine theta for any angle. So hopefully this helped a lot, and good luck in your trigonometry. Next video, we're going to be talking about some properties of angles and angles in the unit circle. So please watch next video if you have the time. Good luck.